Hey, it's time for the secant of x. I will probably make two videos for secant x, one where we generate the graph from scratch, and the second one where there's a little bit of a cheat we can use to enable you to get this graph without having to regenerate it completely every time. So we'll take a look at that. So secant is 1 over cosine, and so in your table, 1 at 0, cosine is 1, and so 1 over 1 is 1. And so we're going to have our first value here at 1. Now at pi over 2, cosine is 0, so that's going to be 1 over 0. So we're going to have a vertical asymptote at pi over 2. You can go ahead and look at your table. We're also going to have a vertical asymptote at 3 pi over 2. And we're going to have cosine of pi is -1, and 1 over -1 is -1. So we've got that value. And at 2 pi, we're back where we started again at 1. So then the question is similar to the last one. From the y-intercept at 0, comma 1, where do we go? Do we go up or do we go down as we approach pi over 2, moving from the left to the right? And to answer that question, first off, we think, well, we've got to do one or the other. It's got to go up or it's got to go down. And secondly, we are in the quadrant 1 region, so we can only have positive values between 0 and pi over 2. So that precludes us going down. We have to go up. And so this graph from the y-intercept is going to go up. Now, if I look at what happens between here and here, between pi over 2 and pi, that matches quadrant 2. And in the second quadrant, the x values are negative, so the adjacent side of my triangles would be negative. So cosine is negative in the second quadrant. So coming from the left side, this is going to be coming from negative infinity up to that point. In the third quadrant, x values are still negative, and so this is going to just run right back down into negative territory again. It cannot break into positive territory. And then when I get to the fourth quadrant, x values are positive again. hmm Okay. And we'll wait, just like regular school. You got to wait for the intercom announcements. And okay, and now, all right, in the fourth quadrant, x values are positive, so cosine is going to be positive, and so that's going to sweep right down. Now I've got a matching spot here at 0, comma 1, and at 2 pi, comma 1. That's where the graph starts to repeat, and so from here, this is going to just continue up. On the left side of the graph, I will have asymptotes at negative pi over 2 and negative 3 pi over 2. And I will continue to have these U shapes. That wasn't a very good one. Sorry about that. Opening up and opening down in an alternating fashion as we go across the graph. These are not parabolas. Don't call them parabolas. There are lots of U-shaped graphs that are not parabolas. Parabolas have to do with the x squared and have very specific geometric properties. And so every U-shaped graph is not a parabola. Don't make that mistake. But so we've got alternating U's of going up and down. And so we would expect now as we go into cosecant that we're going to have other alternating U's going up and down. But based on what we saw from tangent to cotangent, asymptotes are probably going to be in a different place. And where the U-shapes are located, we expect that to be different. I'm going to go ahead and show you this. There's a relationship clearly between this graph and the cosine graph. And if I were to graph the cosine graph, which I'm going to go ahead and graph it in red, the cosine graph starts here at 1, comes down, it's here like that, from here. And so what you can see if you match up the cosine graph with the secant graph, everywhere, biggest thing, everywhere that cosine has a 0, Secant is going to have a vertical asymptote. And everywhere that cosine has a max or a min, that's where the U shape, or that's where the two graphs would meet at ones and negative ones, and then graph from there. So you can actually use the cosine graph to graph the secant graph. You will really want to memorize your sine and cosine graphs because they're super key to answering all kinds of problems, as you'll be seeing over the next few videos. But in this case, if you said, okay, I need to graph secant, that's 1 over cosine, I could start by graphing cosine. Then I could put asymptotes at all the zeros and hook the U-shapes to the cosine graph, and then I could end by, and I won't be able to do this on the smartboard because the eraser's too big, it'll erase too much, and then you just go back and sort of erase out your cosine graph, and your secant graph will be what's left. Um, so that's a way. So that was what I was going to show in another secant video. I'm not going to make that video. I'm just going to, we've already demoed it here. So you can do this in the reverse order. You can start with the secant graph, or sorry, start with the cosine graph and build the secant graph off of it, and then just erase your cosine graph once you're done. Or you can generate it from scratch the way we generated it here. You have those two options when you're doing the graph of secant, and you'll have the same situation when you are doing the graph of cosecant.